So today we're mostly going to be talking about Git. I'm gonna try not to get too technical. I'm gonna do a little bit of a demonstration, but I'm just gonna talk about the advantages, stuff we use for our team. I just want to go around the room and kind of gauge experience a little bit. I got a few mentors in here, but just for kids, what year? If you've used Git before, just real quick. I don't want to take too long. Just name if you use Git, and then your year maybe. So if we could start over here, whoever wants to go.
Like year we came?
Your year in school, yeah. Yeah.
Junior, I've used Git before.
Okay. Your name?
Owen.
Owen, okay, cool.
Junior, I use Git every now and then.
Yeah.
And what else?
Your name?
Azus.
Azus, okay.
My name is Alex. I sometimes use Git.
Yeah. Cool.
I'm Elena. I barely use Git.
Gotcha. Cool. Got it.
That hurt.
Hello, I'm Gio, sophomore, and I do use Git quite a bit.
You do? Awesome. Cool. Got it.
I'm Aiden, I'm a freshman, and I use Git regularly.
Nice. Okay, cool.
Alejandro, I'm a sophomore. I never used it before.
Yeah.
Long-term, I'm a sophomore. I haven't used it.
Got it. And
I'm alright. I'm a freshman and I've used Git quite a bit.
cool. Okay, and then that's my teammate over there. So, yeah. So most of the time, a lot of times we don't really use Git, or when teams try to introduce it into their workflow, it kind of doesn't work out. And that's really common with our team too. When I was a software member, I was the only programmer on the team, and it was kind of just me, like, every once in a while I'd send a commit to my GitHub just to have it on there because FRC want to make it publicly available. And most of the time, I think a lot of teams don't really take advantage of it. I'd say bigger teams with more mature repositories definitely use it a lot because they have a lot of programmers, but for single programmer environments, we don't really use it that much, or it's not really necessary. So I'm just going to go into, but not knowing Git or not knowing much about it is very common, and I wouldn't feel bad about it. I'd say even after this session, even seeing the advantages, there's a really good chance that you won't use it just because it doesn't make sense for your season or anything like that. So, but I'm just going to go over kind of like a brief intro to it, how I use it at my job, and trying to show you, like, on the computer, like, literally examples of how it can benefit you. So let's try to go to the next slide. All right, my name's Jason. I'm an alumni of 3859. I was a software member. Right now I work as an embedded flight software engineer at an aerospace company. And my current work right now, I'm developing on microcontrollers, so really low-level development. That's C++ for power systems on satellites. And so that's what I'm currently doing, and really, when I was on my own team, I didn't really use Git that much. As I said, it was kind of just one-offs. But now that I'm actually working in industry, I'm kind of forced to use it with my team, and I can really see the benefits. And I didn't realize how advantageous it was until I actually got into it. Let's see. Sorry, this is distracting me. And I'll have to apologize today. I'm a little bit brain dead from a heavy work week, so just bear with me a little bit. But let's go to the next slide too. So what is Git? So Git is it's considered a distributed version control system. So basically, if you do program on the robot, you kind of have something that looks like this in your VS Code. This is all your code pertaining to your robot. Most of the time, the only thing that really changes is source, and that's where you put a lot of your, whatever you change in there for your robot. And this folder over first project is considered a repository. It's a central location where you store all your files. FRC. So what a distributed version control system does is it actually stores the entire history of your projects. From the moment you initialize your project, every time you commit, and I'm going to use commit a lot, I'll explain that later, but every time you basically save your files, it gets stored in history. So what Git does is it adds data to your existing repository. It layers on additional metadata. So when you have this right here, on the background, I can go in there and kind of revert several versions back. I can store different versions of this single repository, or I can, I can work together with teammates, and we can all store this on separate computers. So that's what distributed is we have a central server, which might be sometimes GitHub, GitLab. How's it going? Feel free, come on. Damn, you guys got the fancy food. So when we have this kind of extra data in here, every person that has this copy of our repository, they don't only have a copy of our files, but they also retain a copy of our history. So when you share from person to person, they also have the exact history that you have. You guys are all working from the same spot, and then you have a coordinated way to merge that together later. And that's really important for a collaborative work, and we'll go more into that later. But just something to know is that when you use Git on your project, it is determined usually to be safe. Most of the time it is safe. It only adds data on top of your project. It never destroys or removes data from your project. And this is true most of the time because operators are still able to, with some shady command line commands, mess up Git and your repository. So just watch out for that and know what you're doing when you're working with this. And then another thing with Git is you have the ability to work offline and online. So most of the time when you're working online, that's your GitHub server, GitLab server. There's other providers too. But a cool thing about Git is it also works offline. You can store the whole repository and its history on your own computer, and you can work on that individually. So when you're at competition and you're not supposed to be using your Wi-Fi hotspots, it still works. OK, let's go to the next slide. OK. So when should you use Git? In life, it typically when you deal with source code, and robotics, you're always going to be dealing with source code unless you're, I don't know, messing with text files. But most of the time, you will be working with source code. And I would say if you only have a single programmer on your team, sometimes Git does lose its advantages, but I would say on a personal level, storing all your history is the advantage when you're working alone. Otherwise, when you need to make changes, so let's say Sam's working on, that's Sam over there by the way, Sam's working on the shooter, I'm working on the drivetrain, I want to make a change to my drivetrain in my code. Sam doesn't necessarily want to make that change, and Sam wants to continue to work on the shooter. I can make changes on mine. I can break my own code, and it shouldn't affect Sam. Because Sam could be working on a different branch, and we'll talk about branches too. But basically, it's this shared history, so we're both still working towards the same goal, but we could separate it out and merge back later when we need to. And then Git is also, if you're afraid of command line, FRC does have VS Code. I have some opinions about VS Code, but it does offer a GUI, so you don't have to get on the command line at all if you don't want to. Although I would definitely prefer using the command line. There's also plugins, so that's what I'm talking about with VS Code, but there's also a GUI with GitHub. It's like a desktop thing. I've checked it out a little bit. I don't really like it, but it is available. OK, so this is your life when you're not using version control. Every time you save your files, you are actually saving in a, it's kind of like weird, it's contradictory, but you're saving in a destructive way. Because the previous state of your files, before you made your changes, that version of it gets lost. So I don't know about you guys, but when we're at competition, I think someone brought up hero coding. I myself am a hero coder. So literally before a match, when I was a student, I would change a ton of lines, deploy it, and be like, all right, it's ready for competition without testing. Obviously, that's bad. I got away with it way too much. But how this hurts us is if you introduce a bug into your code. So let's say you create a change in your code that will help you fix something or a feature. And then later down the line, you're in the middle of competition and something goes wrong. It didn't go wrong when you initially tested it, but now it is going wrong. And you have no way to revert back to it unless you, manually saved it into a different folder, saved it into a different file. You don't have any way to revert back to it, and it's harder to track down those bugs. So on-the-fly changes, and then, any prior code you have is inaccessible unless you've manually saved it in a different file yourself. So you only have the current version that every time you click Control-S, which is super easy to do, you lose a lot of data behind. OK, let's see. OK, and then thank you. When you're collaborating, each individual programmer, I think there's a school with three laptops, right? If you guys want to share code, you have to manually, email, USB drive, OneDrive, whatever. You have to manually give out portions of that code to each other. And if one person makes a change on their code, now they have to go back and share it with you guys. And if you've made changes on your repository, now you have to manually copy and paste every change that they've made and implement it into yours. Git is really good at automated conflict management. So when you have merges, two different pieces of code, they have to have the same histories in Git, but you can merge them together, and then it presents all the changes that you've made to you, and you can merge it in a very clean interface. And I'm going to show that to you later. But it's very easy to do, and you don't have to, as the programmer, you want to be as efficient as possible, and you don't want to do that yourself. There's like a lot of other reasons that conflicts can happen. It's kind of a huge lake to dive into, but just know that it becomes, I think, code spaghetti when you do it this way. Yes, and then also bugs. There's no custody. You don't have custody over your code. You don't know who did what, who introduced what changed. You don't know where the bugs came from because everyone's working from the same files with no data behind it. So it's really hard to track down bugs when one individual introduces it into the code because you as a programmer, you didn't necessarily introduce that, but they did, and now it is affecting your code. So there's also kind of a lack of division here. Okay. All right, so this is kind of just word soup, but what commits are is how Git works is with our repository. Let me start. Every time you commit, it's basically like a save. And other version control systems, I don't really know what they are, but they're a little bit different. They start at a base file, so you have your beginning file. And then every time you record a change, you're recording a thing called a diff. So you're not saving a new file. You're actually saving kind of like the difference from getting A to B. That's what you're saving in every commit. How Git works, it's a little bit different. Git takes a snapshot of your whole repository every time you commit. So there's a copy of all the files that you have, and it just takes a small, really efficient snapshot. So it basically is like every time saving a whole new folder, but it is all encapsulated, and it is very efficient on storage. So what that means is if I have commit A and commit B, I have both versions of these stored in memory. And then I can also compare these two versions and create the diff instead of only saving the diff. So I'm saved both of these copies, and if I want to go back, I can always access this copy later in the future. And that's one of the powers of Git. Otherwise, branches, what branches are, is if we start from a related history, we start with one file, and Sam wants to start her shooter, she can branch off and start creating different things, and then I can branch off and start creating my things. And since we have a related history, A, we can come back, and there's a variety of ways to merge, but we can come back into the same uniform history. So branching is really powerful because two people who are working on different pieces of code can have that related history and work towards a different goal and then come back in later. And as you can see, B does not affect C. So every time Sam has an issue with code, it does not affect me until we merge. And this separation is actually very nice because I hate it when bugs kill my code. Okay, so that's what branches are. Yes?
So, will it, software these days is made up of multiple files and whatnot. Is Git only, you're working on file A and I'm working on file B, or if we're both working on file A and doing different things in there?
Correct. We can both work on file A. So that's
Merge those changes.
correct. Yes. So these A, Bs, and Cs, they're the same repository. We're working in the same kind of folder area. And what it is we kind of like have a management of our own repository. So whenever I make changes in this repository, it's local, obviously, right? But how the Git is powered is we have kind of the same lineage. So it tracks our differences from A. And then when we come back together, it tracks, okay, this is different here, and then it detects if you have conflicts. If you have conflicts, then it presents them to you, and you can manage them kind of on this merge process. And it also streamlines that process for you. So like, I know what you're saying, where if you guys have the same files, and on line 1, you both say, okay, I need this, and I need this. Obviously, when we go back to merge, this is a conflict, because this one wants a lot, this one wants less. So what Git does is when you queue a merge, it says, okay, these lines are in conflict with each other. This is an issue. And so then you resolve it as a team at that point, or as an individual programmer.
Is it possible that, so say you're working on something,
Right.
and you're on the same program,
Mhm.
you're doing stuff based on assumptions elsewhere, things that are happening. I go and I change other parts, which
Mhm.
then change what's happening in your code.
Right.
So, like, maybe you're assuming that, the number of hours in a day is 24, and I change that to 22.
Mhm.
We merge it, and then all of a sudden your code stops working.
Right.
Git can't handle that, but that could happen, yes?
Right. So when something, yes, correct, that could happen. When that happens, generally you want the programmer to handle that. Git just presents it to you. So I kind of like what we could do in that process is if I have my branch, like B, C, I'm working, I'm making changes, and then all of a sudden Sam's like, you messed up, Jason, I'm gonna make this change. What I can do is I can initiate a merge off of this. So this, let's say this is another branch, I'm like, okay, crap, I have to deal with this. Before I merge back into my singular history, I wanna absorb these changes into my, sorry, this is bad, into the changes I've made. So we can, I think that's more of a how a team wants to do it type of question, where if you make upstream changes, upstream is anything before you, any history before you. If you make upstream changes, I'm probably going to want to preemptively merge your changes that you made into that. But I'm going to go over two things, and it's going to be a little bit confusing, but there's two ways of handling that. Okay, so branches. Okay, merges are, I talked about that a little bit. It's when you branch off from your original code and then you want to bring it back. You've made your changes, you've tested. That's also another thing is like when you make changes upstream and then this change, let's say this change is good. You know this is predictable, this code works, this is good, but this doesn't work anymore. Instead of just making this your main repository, you can merge this into here, figure out what's wrong on your local level, make those fixes, and then decide to merge this back into your normal lineage. So the separation also works when you're fixing bugs and when you're merging other branches into your other branches too. So that's a little bit confusing. I'm sorry I did not word that well. But I will show you guys in a second. Okay, otherwise, rebase is a different, there's two things. There's merges and rebases. I'm gonna show you guys what that looks like later. There's also squashes. I also use this at work, so I'm gonna show you that in a second too. Just figuring out how much I've left on these slides. Okay, so I really wanted to show you guys kind of the repositories we have at work, but my work laptop, IT got so good at their job that they locked me out of my browsers. So I can't do that anymore. But typically what we do is we use a rebase workflow. We don't really, we do merge. It's still the same as a merge, but it's kind of a different process. And then we also use a thing called squashing, which I will show you too. But one really cool thing to use at competitions on a local repository, this is on your local computer, is you have two branches. So there is a branch called dev and there's a branch called release. So this is really helpful because these are kind of like the same lines. These have the same history. And when you're making on-the-fly changes, I have a software guy named Chris. He makes a bunch of changes and never commits to Git unless I force him to. I leave him in this branch. So I say at competitions, every time you make a change on the robot because of necessity, you kind of add these commits to develop. And these are all located in their same branch. These are separate. And then release, it's kind of like something you can also call this, it's stable. So these stable releases are code that you define and you know as working. So you can always revert back to it. This is for just keeping track and making sure that any changes that happen, you can always return to your start point. It's like in video games when you make a mistake and you just load your game back, right? Having this can all happen on the local level. You don't even need to touch a server. Every time you make a change, you go in the competition and it works, good. never release it to stable unless it's fully tested. And this is really important because there's a lot of bugs that happen in very specific scenarios. And if you don't have the stable release that you can quickly, very quickly in the middle and deploy back to your robot again, you've kind of screwed yourself over. So this is what we do on our satellites. We have this is called the working branch, and whenever we're slowly making changes, and then once we've done all of our testing, which is very rigorous, then we release it to stable. And that's kind of just like a little, not really super impactful, but kind of a nice strategy to use.
So that dev one, you're putting on the robot after.
Correct, yes. Yeah, it would be like, that's the branch I have open at all times. Every time I commit, I would commit to that. And then like maybe after competition, or if you're like super, super certain, then you can release to stable. But it's not super crazy because you can always, git log and go back in your history and kind of return to any point in your history. But that's kind of just, a more structured way of doing it instead of fishing around for commits from the past. Okay, so your options, usually there's GitHub and GitLab. The Elk Grove Unified School District, which is this school district and also my school district, blocks GitHub, which is horrible. So there are also other providers like Microsoft and JetBrains. It's just a server. It's really nice to work off of a server because the server acts like a central repository where you can store all your data, and then everyone else kind of works off that server and pushes their changes to that server instead of me going like, okay, hey, let me update your Git. Hey, let me update your Git. So that's what the server does for you. And I really like GitLab. GitLab has some really nice features. You can also self-host it if you do have like a Raspberry Pi or something. So that way, no school district will ever block you. Okay, so I'm gonna pull up actual Git and show you guys some stuff. Can I get that HDMI cable? Thank you. Okay. And then I will also be releasing, I think I sent my email, but if you guys are like seniors or juniors and you guys are about to go to college, eventually my company does offer internships every once in a while. So if you just want to reach out to me, I can send you those job postings when they come out, if you're interested. But also, if there's questions, today's not my best presentation mood, so I am happy to answer questions remotely if needed. Is this my computer? Yeah, we can. All right, cool. Am I blocking you guys? Yes. No, you're good. Yeah, appreciate it. Yeah, we'll do that in a second. Okay. Git stuff. All right, so first step in creating a Git repository is obviously finding it. So I'm gonna try to remember my Linux stuff. Uh-oh. That's too many arguments. Oh. Will that do it? Okay, so that should work now. Okay, this is gonna piss me off. Sounds good, thank you though. All right, I'm just gonna do this. There we go, okay. Sorry guys. All right, so I'm gonna do a git init. So what this is, it's git bash. So this is Windows, but git bash is basically Linux. And if you're using a command line tool, this is like, it comes like when you install git, this comes on your computer. Git bash lets you do a lot of things. You can also use it just to interact when you're programming on your computer. A lot of FRC, you don't really do a lot of stuff on your computer, but it becomes important later when you're doing. Yes, sorry. Yeah, so you can create I mean, you can use any terminal as long as it's installed on your path, but Git Bash can definitely do that, yes. Okay, so I have my Git init, and then I've created an empty repository. If I do my Git, this is called Git log. This is kind of like how you look into your history, and obviously I don't have anything. Right now I have my mainstream branch, which is called master. My original stuff. And then I can do things like create files. So the Vim is just like a word editor. So I'm going to make a file called hello. And I'm just going to talk to myself a little bit. How are you? I think I'm in insert already. Yeah. Sorry, I am. This sucks. Let me sit down with you guys. All right. Okay. So all I've done here is I've created a file that just says, how are you? And now what I'm going to do is I need to configure my username. So this is what I'm talking about when you do git config username. So if you are using the same machine, there we go. If you are using the same machine and you guys are committing to the same repository from the same machine and you're not using GitHub or anything, you can do this, and every time you commit before, it kind of marks that commit as being yours. So it looks like it's already configured. So now I'm going to do git add, and I'm basically, since I'm inside this folder, what I'm doing is I'm saying, hey, git start tracking all the files inside this folder. And if we look inside that folder, I didn't create it yet. Okay. That's weird. Oh, it's because I'm in my root. Sorry. I swear this worked yesterday. Make directory. What did I name that stuff? Thank you for that. All right, there we go. Thank you. So we have these things available in here. So we have hello, so I'm just going to add all that, and it's going to add it, and then I'm going to do a git commit. Okay. So it automatically brings up VS Code. Normally you do this in the command line, but right here I'm just going to add a message. This is my first commit. And this will be relevant later. So I'm going to save this, and then you close this, and this will recognize that, and I've created my first commit. So if I now do my git log, right here what we have is commit and then our hash. That hash is a unique ID for this specific commit, so you can always reference it later. And you see where it says author, that's me. So every time you do like a git config, I'm going to just change my username to something else for now. Did I do this right? To just JSON. Okay. Now I'm going to do a change to that hello file. And I'm going to insert something else. Okay, and now I'm going to make sure I track all my changes. So I need to add it again, and then I can make another commit here. And you can use VS Code if you want for this, but it's not necessary. It will pop it up on that command line for you, too.
So
yes.
Every time you want to do a commit, you have to add the files that you want to commit.
Yeah, and I can show you that in VS Code, too, but basically, there's 3 levels of your working repository. There's repository, there's staged, and I think there's the actual commit data. What you do is when you're working, you stage your changes, and then you add that to commit. So you can make small changes, and then just add certain changes and not add the other ones when you make a commit.
Okay, so if you have like 2 files, and you change them both,
Mm-hmm.
you know, file A, you're done you can just add file A and commit that.
Correct. Yeah. Okay. So I made that commit, and now I can do a git log, and then I have first commit and second commit here. And obviously my author changed, so that's a solution if you want to work from the same machine. All right, so now let's do a thing where I can. So right now, if I open my file here with something, probably WordPad. All right, that's the file I've created. I'm currently in the status of my second commit. That all looks good, Phoenix stuff. Now let's do a git checkout, and I'll show you how I can go and check out my previous commit. Okay, so basically what I've done is I've detached from my most current history, and if I actually go back in here and I open this file again, I should see a change. I've reverted back to my first commit, so it doesn't have that second line I've entered before. And so going back in history is as easy as doing that. You can check things out, and then if you're in VS Code, you can actually deploy this previous deployment, and it's bug isolation. If you want to go into a different branch, you can do that stuff too.
But you still have the word change.
Correct. So now I'm going to go back. So I'm going to do git checkout master, and this returns me to the head. So this is the head position is the most recent position. So now if I go back into my files and open it up again, now I'm at my second commit. So we have our complete history right there. And now this is like, hey, you made some changes.
And if you're doing it through the command line like that, it doesn't matter what editor you use to change your file, whether it could be Vim or it could be Notepad.
Yeah, you can do whatever you want. So and Git will also recognize if you've made changes. So if I just, you do have to save it before you do that, but I can go in here, like blah, blah, blah. Okay, I actually did what I said not to do. Okay. Okay. So I added that, and then I do a git commit. And if I look in here, and I open up this editor here, it shows you all the modifications that you've made. So if you've made modifications to different files, obviously you have to add it first, but it shows you, hey, you've made modifications to this file. What Git also does is even if you add everything again and you've made no changes to a file, it'll say, hey, there's no changes to this file. I'm not going to store it again and take up space. I'm going to store a reference to your, non-changed file.
Development environments, you can actually do after he does his commit,
Yep.
and then change the file again, but don't add it.
Okay, and then I'm going to
Just change the file again.
change it.
Don't add it.
Gotcha.
Change it. Do Vim and change something.
Oops. Okay, I'll add the hash.
This is the change.
Okay.
Okay, do git status. And now you can see the file modified. This really helps in a development environment. If you go, hey, did anyone change any files? No. Someone changed this file.
Yeah, and all of it's really intuitive. I think it's easy to use once you sit down and actually go into the commands. I think the hardest thing with introducing it into teams is actually getting the kids to start using it, because
I think I'm only going to talk to them in Git.
yeah, that's your language now.
Yes.
You have to Vim from now on when you do your robot code. Yeah, I mean I have my current software kid who's the senior. He knows how to use Git. He knows how to do all this stuff. It's just when you're in competition mode and you want to make all these changes and you're like, I don't care about Git. I'm just going to save, do all this and not care the world about it. That's what you have to get over.
And also, too, what's helpful in some of these cases is them having a Git history, so that when they go to talk to college recruiters and whatever, they can say, hey, look, I worked on these projects and actually I approved.
Correct, yeah. So
For a single developer, that's still helpful.
Yeah, and I'll bring that up too, because so what he's talking about is Git is a really good way to show your contributions. So if you go onto GitHub, and I don't have a crazy amount of contributions on GitHub because I do use GitLab, but we sign in. Oh, okay. It's really good to have a record of everything you've done. So if you ever work on a coding project, no two-factor. That's safe. Yeah, that's not good. Okay, so this is kind of, here, I'll show you my most current one. And it's both a bad thing and a thing to show you contribution, but let's see, 2023. I'll show you the history on this. This history to me looks very ugly, but yeah, not bad. But these commits are garbage commits. So basically what we have here is just a really not good strategy to have is creating all your feature branches at once unless they're actually being used. So we have a lot of feature branches here that, so look at this green branch here. We've made all these upstream changes. We've merged all these branches back in here. And how's it going, guys? You want to take a seat? We made all these changes, and then we merged it later on. I'm telling you, when they made this merge right here, that was painful because you have all these conflicts that you have to solve. What they should have been doing is every time you make an upstream change, you should be merging it back in your main commit. And sorry, that's just a rant. I just saw that now. But basically, if we look on here, this is really good for your resume because we can go to contributors and we'll see. Okay, so this is my main software guy, 24 commits. I'm telling you right now that we made way more than 24 changes. But he does have a lot of commits on record. This goes on his profile. You could put your GitHub on your resume and people will see this. I've only made 2, and then yeah, so, and you can also see what changes you made in code, and this is also custody. So you know who did what individual things, and this, what else were we talking about? Just contribution in general.
Contribution
in
in general. Just showing that you have some kind of program user.
Right. And so like this project is available to anyone who's looking to get you an internship. They can see here, oh, Christopher, he's the #1 contributor to this repository. This code looks, decent. That's cool. And knowing how to do Git is very important. If you ever want to be a software developer, very rarely will you ever have a workplace that doesn't have version control. And if it doesn't, you need to implement it as a software developer. So very important stuff. I didn't realize it. Like, honestly, I was horrible. Every year during my season, I was like, hey, let's use Git, guys. We're going to do it. And then I never did it. And then I get to work, and my boss is like a Git master. And he's like, oh, you can't do this? What have you been learning all these years? You're not a real coder. I know. He's like that sometimes, but it happens when you're in a workplace. But that's GitHub. So GitHub is really good if it's not blocked. There's also other features on GitHub that you can use. So one thing I like to use on here is issues. Issues are basically like when there's branches, right? And then you want to have some kind of like text, some context for your branches. So I've created a branch called motion profile. We want to implement a motion profile. This is just some text for myself, but basically in GitHub, you have these tools to have a dialogue with your team. And here I've assigned Chris, and I said, hey, we have a second motor that doesn't need a motion profile. Knock that out of the profile, and then continue tuning your profile on that the single motor. And so this is a bug. We have an issue with our arm. So I'm telling him what to do. I want him to create a branch. So I think he's made a branch, but he hasn't linked it to this issue yet. But you can link your branch to the issue, and then once he's finished with his branch, he goes in here and he says, Jason, I'm done with my branch. I need you to review it and then merge it in. So this whole history is all related to the branch, and this is a collaborative tool built into GitHub. This is not a Git thing. This is a GitHub thing. But it uses the Git API to kind of facilitate this. And within here, you can also have project management, so you can have milestone. Milestone for us is MVP. We don't want to get too crazy. Minimum viable product. We don't want to get too crazy with our code. The least we can do is at least get the robot driving. So some issues can be linked to MVP. We knock those out early in the season. We've had it all tracked, and then we can move on to our next milestone, which can be like motion profiling, advanced autos. We never make it that far sometimes. But really good to track in here. And I'll show you the project pane too. This is also, you see this in other version control repository servers too. This isn't unique to GitHub, this is everywhere. But within our team, this is the project that links to it. And I don't know how much I hashed this out, but this is kind of an overview of several repositories. So this helps when you have like new programmers too. Obviously, you want to get them indoctrinated to the process very early. So here we have, this is Sam, my teammate who left earlier, but Sam is working on a repository inside our off-season bot. Chris is assigned to a crazy ton amount of branches from our current robot for this tournament right here. For our main robot. And so you can manage these are all issues. These are individual issues, and these are things that you want people to open branches on. So if you're a lead software person, you could take advantage of this to kind of like have an overview of what's going on in your projects. And I introduced some milestones. Initial structure is, this is for the 2024 robot. We just want to have like general initial, like what people are working on. You need to start with the history, so that usually that's just go and make your template code on WPI library. Get that initial structure done. Create a hardware map. Obviously, hardware doesn't change that much unless you introduce a new motor later in the season, which is crazy. But once you get the hardware down, everyone knows what they're working off of. And usually, if you guys use command-based robots, a lot of people should be. Usually, you have one kid working on one subsystem, so you don't have a lot of conflicts. But if one kid messes up their subsystem, it doesn't affect everyone, type of deal. So this is, yeah. And so these tools are really useful. You can separate them out in all sorts of ways. But this is what I've been using to help organize a team. And this is what I use at work too. Obviously, milestones are a little bit more in-depth when you're at work because you have to prove to corporate that you're actually doing something. But
It's actually helpful for a manager to come in and see
right.
you're doing some missions and stuff like that.
Yeah. And then, I mean, shoot, if you're writing, we're half the awards that you can say, hey, this is how we manage our projects. FRC, look at how we do all this. It's good stuff, and it's all free. It's built in. So, yeah, at the very least, if you don't want to use projects, I would take advantage of issues, because issues are a really good way to kind of like track who's doing what, if things are actually getting done, and then also code reviews. Another benefit about Git is you do a lot of things called code reviews. So if I want to do a merge, I'm going to simulate one real quick. I'm going to go to, I don't think there's any changes in these branches yet, but I can do a thing called a diff, which I don't know how to do in GitHub, but basically what you saw here, actually let me do this. I don't know how much time we have, but.
We have a bunch of good start the next sessions.
Okay, I say let's just end it here. And then if you have any additional questions, I can get to you afterwards, but I'm going to release you guys if you want.
Alex wants to get your
Oh yeah, email, so let me put that back up. Yeah, definitely reach out to me if you have any questions. I'm usually better answering things over text. But every once in a while, my work pushes out internships, and they're really cool. You get to, with these internships, you actually work on the satellite, which is rare in internships. So. But they do come out every summer. I would say this is more of like a college thing. Once you're in college, and actually, let me put my work email in there too. Yeah, go for it. Okay. So yeah, definitely keep me in mind. The team that I'm a part of, it's like a growing team. I'm currently working remotely, but there is opportunities in New Mexico, down in Vanderburg. So whenever I see those internships, if I just get your emails, you just send me, say, hey, I'm part of FRC, I can send them out to you when I get them. I'm not sure how often we hire freshmen in college, but it's definitely possible, if you know Git specifically. But we do a lot of C, C++ work. We do a lot of C#. And we're doing a little bit of Rust, but I'm not sure if we're going to go with that. So yeah, just reach out to me, and then I'll take questions too if you have them. Sorry for the Git. It's usually boring, but thanks for bearing with me. Yeah. Yeah.
So if there's a repository and somebody wants to work on something in it for the first time, what's the procedure? How does that happen?
like how do they get it on the computer? So typically, what you do is,
We gotta head back upstairs.
yeah, go to the competition, go have some fun.
Thank you all on the live.
Appreciate it.
Yeah, you got it. Thank you for coming.